I'm Dishita, and I'm very excited today to talk about our work on identifying the game mechanics for integrating fabrication activities within existing digital games. Combining fabrication with the playing of digital games provides opportunities for players to construct objects from their gameplay and bring the digital content into the physical world. For example, every time you capture a Pokemon in the game Pokemon Let's Go, you could fabricate a physical collectible of it. Or imagine fabricating the rare sword acquired in the game Legend of Zelda and using it as a game controller. In our prior work, we built a toolkit that allowed integrating fabrication within existing digital games and auto-generating the fabrication files for the game objects. And our studies demonstrated that using this toolkit, we were able to fabricate objects from a variety of existing digital games played around the world. In this user study, we invited 12 participants to use our toolkit to integrate fabrication activities within the games and the gameplay events of their choice. At the end of the study, they altogether integrated fabrication within 47 gameplay moments of 35 games that spanned across several game genres such as action, adventure, puzzle, etc. While the fabricated objects from these integrated events also had a variety of uses, such as this custom designed dress fabricated for personal collection from the game Animal Planet, and this personalized skateboard fabricated from the game Tony Hawk, and this physical map to guide in the game Professor Layton. While it was great to see so many objects being fabricated from existing games, we were very interested in understanding what do these fabricated physical objects mean to the players. In other words, how do players associate with these fabricated objects? And the reason we care about this question is because from a game design perspective, understanding these associations can help us better integrate fabrication activities with digital games. And we address this vision in our current work, where we revisited the results from the prior study that offer an opportunity to gain deeper insights on the player experiences that emerge from integrating fabrication within existing games. And we analyzed these results using the widely known mechanics, dynamics, and aesthetics, or the MDA framework. But before the analysis, we modified this framework a little by adding the components related to fabrication process. And we call this modified framework as the f-MDA framework. So let me first briefly explain this f-MDA framework using the example of game Animal Crossing and the fabrication event where the player can design their own custom clothing and fabricate it. In this example, the game mechanics of designing and editing allow the player to customize a game object. And once the player completes the custom design, the player dynamics allow the player to add this asset to the inventory. This event is aimed to provide the player with a sense of joy through the process of creative expression, which is what we call the player aesthetics, or the desirable emotional responses evoked in the player. For this fabrication event, the fabrication mechanics are the rules that trigger fabrication and nudge the players to physically fabricate the object using, let's say, laser cutter. The player can then use this physical object for, let's say, their personal collection. Now, the joyful experience of not just designing but also fabricating this object of personal collection can create these new player object aesthetics or associations of creativity or self-expression. From the designer's perspective, the player object aesthetics are an important design component because they can add new experiences within the existing games through fabrication. And because of their personal association with the object, the player might be motivated to play the game differently. So what were some of the new player object aesthetics that emerged through our analysis? The first category is the fabrication of physical objects of pride. For example, when winning the game or acquiring rare assets. One of our study participants, for example, said, when you collect a very rare or a legendary item like this dagger that occurs only once or twice in the entire game, you can fabricate it because it is super special. The other categories are fabricating objects of creativity, like this unique dress from Animal Crossing, and using objects as resource, where these objects can help players to strategically optimize their resources, for example, as currency or construction material in games. The next category is objects of function, where physical objects support the player's progress, such as this map of the village to help solve the puzzle. And last but not the least is the category of objects of shared memory, especially for multiplayer games. A participant, for example, pointed out that when several players play against each other, events of wins and losses can be a fun shared experience, and it would be cool to have these memorable objects fabricated. So now that we know how players associate with fabricated objects from the games, we can use this list of identified player object aesthetics and map it and identify the links between them and existing game mechanics from the comprehensive list presented by Lim et al. Through these color-coded mapped links, we identified which game mechanics offer the potential of integrating fabrication that lead to these 5 player object aesthetics. For example, to integrate fabrication of objects of pride, we can use all these game mechanics available. Or conversely, having the game mechanic of grids or tiles, for example, you could have an opportunity to integrate fabrication of objects of pride, resource, or function. Thus, designers can use this bidirectional mapping in their workflow to integrate fabrication activities within existing digital games. In conclusion, the mapping, the player object aesthetics, and the framework altogether provide insights into how we can design new player experiences within existing digital games using fabrication. And I invite you to read our paper for more details and insights on the contribution of our work. However, our work doesn't stop here. One critical aspect of integrating fabrication within existing digital games is taking into account the timing of fabrication process itself as it impacts the player's experience. This requires further exploration. Another area of future work is how our framework can be used for analyzing other fabrication games that already allow creation of physical objects, and we are very excited to pursue these research avenues. In conclusion, our work contributes to the emerging research on the design of fabrication games with the goal to enhance the player's experience through the physical fabrication of objects and creating these objects of value for players. And with that, I'm happy to take questions and I look forward to your comments and feedback.